Hi everyone, welcome to my new video on how to run CentOS in Firecracker. I'm Michael Mullen and let's get started. So the agenda today is I'm going to give a brief discussion about what Firecracker is, and then I'm going to talk about how we can get any arbitrary Linux distribution that we want into Firecracker. Now for the demo, I'm going to be installing CentOS Stream 8. And I'm doing that because it's one of the harder distributions to get into Firecracker. But the techniques that I'm about to show you in the demo should work for any Linux distribution. I've given it a try with Arch, and Arch is easier to get into Firecracker. So that's why I'm showing you CentOS. I'll show you the hardest thing that I found so that the other distributions can be done easier. So what is Firecracker? Well, Firecracker is a new virtual machine manager that was released a few years ago by Amazon. It's still pretty new, but Amazon uses it in their production. A fellow named DJ Ware on YouTube has done some good introduction to Firecracker videos. So I'm going to assume that you've watched his videos. And if you haven't, I'm going to link his videos down in my description below. Go watch them and then come back, and this will be kind of a next step after you've watched his videos. So Firecracker is similar to QEMU, but it has features stripped out of it. So for example, there's no GUI. Firecracker is written in Rust rather than C, and the whole intention of Firecracker is that it's supposed to be more secure against buffer overflows because of QEMU, and it's more secure in general because features have been stripped out. I believe the main impetus for creating Firecracker was the CVE 2015-3456 VMM security vulnerability. So the problem with Firecracker is there's no easy way to insert an ISO into the virtual machine in order to install it. Now there's on the documentation area of Firecracker in their GitHub page, they show you how you can install Alpine, and the Hello World demo will install Ubuntu 16.04. But I'm interested in getting any arbitrary Linux installed into Firecracker. Well, any arbitrary server-based Linux, because there is no GUI. So, how do we install an operating system into Firecracker? Well, we don't. We cheat. What we're going to do is we're going to use QEMU to install the operating system and then copy the data from that QEMU into a file system that Firecracker can read. We also need to compile our own kernel with a .config that the Firecracker team has set up for us. And there's a few scripts that I have to both run QEMU and to run Firecracker, and those scripts are found on my GitHub page. So you can either take those and use those as I'm using them, or take them and learn from them about how to run your virtual machines, similar to how I do. So let's get on to the demo. So the first thing that we're going to do is we're going to download CentOS 8, CentOS Stream 8. So we're going to go to our CentOS page here, go to the download, and we want the CentOS Stream x86 area. And it's okay to be, well, it's not okay to be downloading it without the HTTPS, but that's the way you kind of have to go. And once you go deeper into it, you'll find that the HTTPS is on the mirrors here. So you go ahead and download the nearly 9 gigabyte version of this because that has the full install that we want. I've already done this, and I've saved that into an area on my hard drive in VM's ISOs. So you'll see that I've got CentOS Stream here. So we're going to be using that to install. So the first thing that we're going to do is we're going to create a QEMU file system, a QEMU drive here. We're going to use the raw file type, and we're going to call it, well, first we're going to make an area for us to work in. So I'm going to call directory called stream. And then I'm going to create a QEMU image of raw type called stream.image. And I'm going to give it 20 gigabytes of size. Oh, we need to create. All right, so we've got that. And now I'm going to run a QEMU and install Centos8 stream onto that image that we just created. So stream, and we're going to give the CD-ROM as VMs ISO Centos8 stream. And we're not going to do just yes here. I'm going to fast forward a lot of this installation, but I'll slow down for the important steps that you need to change from the yes areas. Okay, so this is the first thing that we want to change from the yes. We don't want to be installing a GUI because Firecracker doesn't have a GUI, and we actually want to install as small an operating system as possible. So we're going to pick the minimal install, and we're going to pick the standard installation of CentOS Linux. And we're going to click done here. And then we're going to go into the installation destination area. And we're going to do a custom configuration of this hard drive. So we'll pick custom, then the drive. And we're going to be using standard partitioning. And then we'll just let CentOS create the file system as we want it. It doesn't matter that we're using XFS here. It's just so long as your host kernel can understand the file system that we're going to be using for the root partition. So we're going to click done here. Accept the changes, and we've got everything ready to go here, doing the minimal install, and we will begin the installation. So while that is installing, let's take a closer look. Well, let's see what the problem is that Firecracker is trying to solve here. So back in 2015, this happened. QEMU had not been properly keeping up to date on their floppy disk controller, and someone found a vulnerability that would allow you to execute arbitrary code on the host operating system, I believe, if you had root permissions in the guest operating system. Now, it's extraordinarily easy to get root permissions in the guest operating system because you're the master of it. You're the master of that guest operating system, and you don't need root to be able to run your QEMU session. So yeah, this was a pretty bad thing. So the Amazon people who run AWS, who want to use virtual machines to be able to segment their bare metal hardware into as many kind of as many guest machines as possible so that they can sell you time on these guest machines, couldn't allow a security vulnerability like this onto their machines because that would be absolutely disastrous for them. So they decided to write Firecracker in the most secure systems programming language currently available, which is Rust, and strip out all the stuff like floppy disks, CD-ROMs, GUIs, all that stuff. Keep it as tight as possible to only run the things that they needed to run. So as the QEMU is installing CentOS8 here, CentOS8 stream here, we're going to move on to the next step of what we need to do. And that is we need to create for ourselves a custom kernel. So I have an area here where I keep my keep myself an up-to-date mainline kernel. And that's this mainline directory. And then I git clone this mainline directory to get this Linux directory consisting of an area where I do working stuff inside of the kernel. So let's go into this Linux area. And what we need to do, the reason why we're creating a custom kernel here is that the kernel shipped with CentOS8 doesn't seem to have the necessary configurations to run inside of Firecracker. And I haven't been able to get down to the details of what exactly is missing from the CentOS8 stream kernel. However, the CentOS8 developers, or sorry, the AWS Firecracker developers give us inside of their Firecracker documentation area, inside of their rootfs and kernel setup, they give us a kernel config that we can use to create our own custom kernel here. So I'm going to go in and go into their recommended custom kernel and then click on raw, grab the URL, and do a wget into my working area where I develop kernels for myself. So I'm going to grab that .config, take a quick look at it, make sure that it's not HTML stuff, and it's not, it's the config that we want. And then I'm going to copy that into .config. I'm going to do a make menu config. And then I'm going to immediately exit out. And the reason why I did that make menu config is that this kernel was made for an older version of the kernel. And if you do a make menu config and then you immediately exit out, it'll do all the default configuration stuff for you, so that when you type make here, it's not going to prompt you with a bunch of questions asking, do you want this feature turned on? Do you want this feature turned off? Etc., etc. It's just going to pick all the defaults. So after that, we can do a make VM Linux -J18. And the reason I do J18 is just to speed up the build here. And we will start that compiling. And hopefully our CentOS8 will be finalized very soon. All right, so QEMU has successfully installed the CentOS8 stream operating system, and I'm just going to click the reboot here. And we're not going to go through the whole installation again. We're just making sure that the file system is synced here. All right, so we're at the grub screen here, but we don't want to continue on. We just want to quit out of QEMU because the file system is fully synced. And right at that moment, we got ourselves our VM Linux. So let's move on to the next stage of the process of getting ourselves this Firecracker CentOS machine. I'm going to clear that. Now I'm going to create two directories here. I'm going to create ext4 and raw. Now what we're going to do is let's get ourselves into a super user bash terminal. And I'm going to create an ext file system as a file here. So I'm going to dd from if dev0 into stream cent.ext4, and I'm going to make it 10 gigabytes of size. I'm then going to make fs ext4 onto that file. All right. Now we are going to do a low setup -f to see what the first loop device is, and it's going to be loop 0. And we're going to do a low setup F capital P on stream.image, which is the CentOS, the installed CentOS 8 machine here. And now we'll take a look at dev loop, and we'll see that we've got these loop 0. We've got these loop 0, partition 3, 2, and 1, and we care about the partition 3 here. So we are going to then mount dev loop 0p3 onto raw, and then take a look at raw. And we can see that we've got our root file system here. Okay, so the next thing that we're going to do is we're going to do a low setup of dev loop 1 for that cent.ext4 file. And then we're going to mount dev loop 1 onto ext4. And then we'll go into the raw directory and do a tar create everything in the current directory, and then pipe it to tar deflate into ext4. And we'll take a look at that ext4 area, and we can see that we've got a copy, a nearly exact copy. So there's some differences in these sizes here, but let's not worry about that, because, yeah, don't worry about that. The file, the directories here are fine. It's the it's the size of, I believe, the block size that we chose. We chose the default of 4096. So. But yeah, it's good enough for us, but there are a few things that we need to do before we actually do a boot up of that file system. So let's go into the ext4 file here, this file system, and we want to make sure that when we boot up our CentOS machine, we need to relabel all the SELinux stuff. And the reason for that is that when we did that tarring stuff, we got all of these unlabeled SELinux contexts inside of our new directory, as opposed to our raw, which has properly labeled SELinux contexts. So what we need to do here is just touch a file called auto relabel. And we're going to do another thing here. We need to change the fs tab. So we're going to do a vim of etc fs tab on this new ext4 file system. And we're going to delete the swap and the boot directory, and then change our root to be dev vda. And it is ext4. Oops. I'll put it there. ext4. Okay. All right, quit. All right, so that's what we need to do to get ourselves a first boot going up. So let's unmount ext4. Let's unmount raw. And let's remove those loop devices. So up -d dev loop 1 and dev loop 0. Get ourselves out of root here. And we're now going to use my Firecracker script. And I'll get that over. And you can see what it's all about here. So it's basically the same thing that the AWS Firecracker developers tell you in their Hello World example here. So if we go back and look at their documentation, inside of their Getting Started area, they give directions on how to start a Hello World Firecracker instance here. So I've basically just taken some of that and edited it a bit and made a few changes so that on the command line I can give parameters to it. So the parameters that I'm going to do is I'm going to first run the server version of Firecracker here. So I'm running fc with server, and that's all that this area is going to do. And on this area, I'll go back into the VM directory, and I'm going to do a Firecracker -c for client -K for the kernel of kernel Linux VM Linux, and -R for the root directory at stream cent.ext4. And then I'm going to use the int flag so that we will run as interactive mode. So we'll see things come up inside of this window, and we'll be able to log in over here. So we'll start that up, and hopefully it goes well for us. This is the big test. No, it didn't work. So why didn't it work? It didn't work because inside of the stream directory, my cent is still owned by root, and I'm not allowed to do things with it. So I need to sudo chown to my user everything inside of stream, and we'll give this another go. And we're booting up. We're now going through the relabeling. So it's relabeling our file system to the proper labels that it should get. And this will take a few seconds because it's going through everything on this hard drive. And it does that reboot as part of the relabeling. So now we're going to start it up again. And we are now running Centos8 inside of Firecracker. But we do not have a network. So the next stage here is we need to get ourselves a network going so that we can actually do interesting things with this machine. Because right now it's just basically a window sitting there. So let's first make some changes to one of the network scripts. So we're going to get ourselves a super user shell, and we're going to vi inside of etc sysconfig network scripts, and we're going to change this file so that the device is eth0 and that it will start up on boot. And then we will actually rename that file to we did that wrong. So rename to ifcfg eth0. There we go. Okay. And now we're going to shut down the virtual machine and get ourselves a network going. So we're going to reboot, and reboot is how you actually turn off the Firecracker running instance here. And I'll show. So you can do a shutdown now -h here, but there is going to be a problem. After the system is halted, Firecracker is still going here, so we actually have to do a pkill of Firecracker. And then you'll notice that this terminal is now dead, right? So we need to, if we do that, we need to type reset and enter, and now we've got our terminal back. So instead of going through that problem, you can just do a reboot instead, and the reboot doesn't actually reboot, it just shuts down. So what we want to do here is get ourselves a network, and I've got a script to get networking done over a bridge using a tunnel interface, and I call that script net. And it does some network manager command line stuff to just set up the bridge, enslave my host to the bridge, and then my FC here, if I give an option for the tunnel interface that it should use, it'll set up the tunnel interface as well. So I'm going to do a net. Actually, let's see if I've already done this. IP.k Yes, I have. So I'm just going to do a net down. And that will clean everything up for me here. I didn't get rid of the bridge. Why didn't I get rid of the bridge? Oh, well, let's do a net up. Now a net down. Did it get rid of it? No. Well, no worries. We're still fine with the net up here. And now P-A. Am I able to go somewhere on the network here? Let's go into Google. Yeah, I've still got a network on my host. So now that we've got a network, we will run the Firecracker as server again. And on this window, we're going to run Firecracker for a client given the kernel of kernel Linux, VM Linux, and then the root file system is stream cent .ext4. We're going to run it in interactive mode, and we're going to give it a network of tap 0. So that's what the 0 is for here. And we should have a network interface. So we are now actually bridged to, so if we wanted to, we could SSH into this machine. Well, actually, let's make sure that we can actually SSH into it by system control enable now SSHD. And we can actually SSH into 192.168.0.184 from anywhere on our home network. And we actually have to clean out our known hosts because I've done this a few times. And I'm on the machine here. I'm on the Firecracker machine. So what can we do? Well, we can do anything that we would normally do on a virtual machine, including sudo dnf update. Yes. And get ourselves some fresh new CentOS8. So that's it. We're running a Firecracker instance. We're running CentOS in Firecracker, and everything's good here. I hope you have learned something about Linux. I hope you have learned something about Firecracker and VMs. Have a good day or a good evening or a good morning.